Hello, everybody. This is Mohammad ALQUDAH from Yarmouk University, and I would like to thank NannoTalks for this opportunity. I am now located in Yarmouk University, and I would like to give a talk about the calcareous nanofossils by stratigraphy of Eocene oil shales in Jordan, which it was a collaboration between Shell International and AURORA University of Bochum in Germany. This talk is just to know how the nanofossils can be used as a tool to understand the regional geology in the region. This research has been published in GeoArabia in 2014. So the matter here is the oil shales. The oil shales in Jordan deposit in all over Jordan in the north, central, and south. Lithologically, it is organic rich marl that deposited during the late Cretaceous and Paleogene. So Jordan during the late Cretaceous was a broad, shallow marine shelf. And during to the tectonic, there was effect of tectonic in the basins. So there was a establishment of sub-basins like the Yarmouk sub-basin in the north, Lajoon sub-basin in the central, Jafar sub-basin in the south, and Azraq Hamza sub-basin in the center east. The objective of this study is to understand the timing of the oil shale deposits. This is the first. Build up a framework of age that correlate all the horizons, oil shales horizons in Jordan. So we thought about the nanofossils. Also, by using the nanofossils, we can understand the paleo-depositional environment of oil shales. So we used the calcareous nanofossils. We took samples from many wells in the central of Jordan, OS25, OS23, OS22, OS14, and OS28 at the east. And we prepared smear slides to understand the age first. So after studying these slides, we looked to the groups and we found marker species, calcareous nanofossils marker species like Tribrachyathus, like Discoaster, like Nannotetrina flungens, and Coccolithophorus, Reticulophinestra. Oh, and also we found Paleocene and Cretaceous species in less preserved assemblages. So we were able to differentiate 4 biozonations, starting from the bottom, the Discoaster lodoensis. Then we had the Discoaster sublodoensis, Nannotetrina flungens, and the Discoaster nudifers at the top. We found that there is a match and correlation, good correlation between OS22 and OS23, which is in the central of Jordan, but we couldn't find a match between these two cores and OS28, which is older in age. So we have many ages, and these many ages can be correlate all together. So we have a progradation, regradation of facies of oil shales, undefined and found by calcareous nanofossils. Also, another point which is important, we found Cretaceous and Paleogene, Paleocene species within the Middle Eocene. And based on this, we can differentiate the autochthonous species, which is the Middle Eocene species, from the Cretaceous, Paleogene, and early Eocene species. So based on that, we can subdivide the section, and we got the example from the core OS23 into 5 intervals, interval A, B, C, D, and E. And in these intervals, we can count the numbers of autochthonous and number of allochthonous species. In interval A, we found at the bottom, we found that it is almost autochthonous species without any allochthonous species. Allochthonous species, Paleocene and Cretaceous, appeared in the middle of the core in intervals B, C, and D. And finally, the allochthonous species, and mainly the Cretaceous, disappeared. Then the Paleocene disappeared after that. Based on these differentiation between the allochthonous and autochthonous species, we can understand the behavior of basin and sea level change during the time in overall understanding of the basin analysis. So at the beginning, at the early Cretaceous, early middle Cretaceous, the relief between the host and graben was not that pronounced. So there was a depositional just from the autochthonous. But with the increasing in the relief between the host and graben, there was more comes to inside during the weathering and erosion. And the Paleocene, Eocene, early Eocene, and Cretaceous contributed to the Middle Eocene basins. So we found the Cretaceous, Paleocene, and Middle Eocene. At the end, in the interval E, the relief is less pronounced again. So the depositional environment has changed, and the old shale is retreated, and finally there is no anymore working was in the basins. So from this understanding, we found that the Middle Eocene age was in action in Jordan due to the tectonic events, and we found autochthonous, allochthonous species within the basins. And by counting the amount of the Cretaceous and Paleogene, which it is mixed in the autochthonous species, we can understand the actions happened during the Middle Eocene and the tectonic of the area. So by understanding the complex sub-regional tectonic setting, we can find many sources of sedimentary rocks indicated by the source, by the age of calcareous nanofossils. And when we look to the regional geology, we found that there were effect of a huge event. The first one, which is the Syrian arc, affect our area by increasing the relief between the host and grabens. So this happened during the late Cretaceous and Paleogene. And finally, during the Middle Eocene, the alpine orogeny played a major role in transportation and sea level change, and the transportation of reworked species into the basins. Thank you very much for your attention.